Okay, how did you make out with your problem? Let's take a look at it. We're asked to determine what kind of symmetry, if any, this function might have. Of course, you realize most functions aren't going to be symmetric. It's only a special few that have symmetry about the y-axis or symmetry through the origin. Your book, by the way, also talks about symmetry around the x-axis, and that's another common type of symmetry. However, you have to realize that there is no anything that has symmetry about the x-axis is not going to be a function, right? It's going to fail the vertical line test, so we're not too concerned about that type. All right, so to follow your hint, I'm just going to say, okay, this dependent variable y, I'll say it's equal to a function named f, just so I have a function name that I can work with, because I want to be able to say f of negative x. Let me figure out what this is equal to. If it's equal to f of x, then I know it's an even function. If it's equal to the opposite of f of x, then I know it's an odd function with symmetry through the origin. If it's not equal to either of them, then we don't have symmetry. So, I replace x with negative x. Notice negative x times negative x times negative x. Two of those negative signs cancel out, and I'm left with negative x cubed. Here I'm subtracting negative x. That's the same as adding x. Now, if I factor out a negative 1, which is the same as writing a minus sign on the outside, I get that. Notice the sign change on the inside of the parentheses. And notice also, everything inside the parentheses here is exactly y. That is, exactly f of x. I don't need those outer parentheses there. So very simply, I can state this. F of negative x equals the opposite of f of x. My conclusion is it's an odd function, and I have symmetry through the origin. If you do want to see a picture of what this looks like, well, if you have your graphing calculator, you can do that very easily. But if you're relying on old manual methods like me, it turns out that your x-intercepts are negative 1, 0, the origin, and positive 1. And in fact, the curve looks like that between, in that interval, between the intercepts. Runs off to positive infinity there, runs off to negative infinity there, and what you see is you do have symmetry through the axis. Not perfectly drawn, but you see that in fact it is symmetrical. Okay. Any questions? Shoot me an email. We can set up a Zoom session, whatever you like. For homework, on page 258. Well, first, before you get to 258, go look at your MML homework that is assigned. There are, 2 videos and 3 animations that illustrate this stuff beautifully. They give you a very good understanding of what these various transformations and symmetries look like. Then 1 through 9 odd, 17 through 21 odd, 29 through 35 odd, 39 through 43 odd, and also number 47. So it's a lot of problems, but they're pretty quick, and I think it'll go okay. Okay, take care.